Students, welcome to all. This session I am going to discuss the topic exchange energy. Okay, so till the previous video we saw the stability of an atom. Okay children, atom, any atom, for example carbon, nitrogen, oxygen, fluorine, neon, whatever, any element. If we consider the particular atom, it is very stable, means the outer valence electron is whether it is half filled or completely filled. Okay, so this is the basic concept, you know very well, already studied. Okay, so here this exchange energy topic, it comes under the stability of half filled and completely filled orbitals. Okay, so in the previous session I explained the chromium as well as copper. Okay, in chromium atomic number 24, outer electronic configuration 3d54s1. Okay, now the atom is very stable. At the same time, the same chromium atomic number, chromium 24, 3d4s2. Okay, here write argon. In 3d5, here 3d4. Okay children, so in 3d5 4s1, now the atom is more stable. Why the atom is more stable? Means two reasons. One is symmetry and another one is exchange energy. Okay, so symmetry means, for example, p orbital. Okay, structural representation. Here 6 electron is possible. Now 1, 2, 3. 3 electron is denoted as half filled. Again fill this electron 4, 5, 6. 6 electron is denoted as completely filled. Are you clear? So now in half filled as well as completely filled. Write again 1, 2, 3. Okay, 1, 2, 3. Now half filled. This one for completely filled. So in half filled, 3 electron it is present. This one is denoted as a symmetry, equally distributed. Okay, and same spin. Here 6 electrons. So this also denoted as symmetry. So two reasons. One is symmetry and another one is exchange energy. Are you clear children? So this session now, let us talk about the exchange energy. Okay, so before that, as why this atom we consider as more stable? It depends on. Okay, so now arises some questions. Okay children, so now before that I explain simple example. For example, nitrogen. Okay, atomic number 7. Electronic configuration 1s2, 2s2 and 2p3. Are you clear? Okay, take another one example, carbon 6. Here 1s2, 2s2, 2p2, 2, 4, 6. Okay, so which atom is more stable? Can you say the answer children? Can you guess it? Which one is more stable? See here, nitrogen is more stable than carbon. Why nitrogen is more stable? In p orbital, how many electron? 3 electron. That means it is in the form of symmetrical pattern. Okay. So at the same time in carbon. Okay, how many electron? Only 2 electron. This one it is denoted as partially filled electrons. Okay, so compared to the partially filled electron, now it is the symmetrical, equal. Okay, at the same time as the same spin equally distributed. So nitrogen is more stable atom than the carbon. Are you clear, children? So now here two, that is example, one is chromium as well as copper, and they explain why is more stable. Okay, and next one they are saying the reason. So reason means only symmetry and another one is exchange energy. Okay, so in another one way they are explaining the shielding concept. So shielding concept, shielding effect, you know very well. I explain once again. Center of the atom is the nucleus. Electron is revolved around the nucleus. Okay, so here electron present, here also electron it is present, 8 electron, here also electron it is present. Okay, so here also some electron it is present. Okay, so now nucleus, here electron, attraction, but the previous shell it not possible to make them to attract properly. Okay, so this electron make them to form the shield. Okay, so due to shielding, this attraction is very less. Are you clear? Okay, now without shielding, attraction is more. Nucleus as well as electron, without shielding, it is more. Now in the presence of shielding, now the attraction is less. Okay, so this is process is known as shielding effect. Okay, so in symmetrical distribution, especially in half-filled electron, now the shielding is less. Okay, so the shielding, here shielding means attraction. Okay, talk about the attraction. Okay, so in half-filled configuration, now this attraction between nucleus as well as outermost electron is more. Okay, so shielding is less. Shielding less means attraction that is more. Okay, this also another one reason. Okay, in a textbook given this diagram, this one for p orbital. Okay, p orbital. How many orientation? 3 orientation and 6 electrons. So 1, 2, 3, half filled. Okay, children. So here single electrons. Okay, so in the single electron, now attraction is more, shielding effect is less. Okay, so now increase the stability of an atom. Are you clear, children? This whatever now I explained, already explained the previous session also. Okay, for this session I'm explaining the exchange energy, just to recall part. Are you clear, children? So now study the topic exchange energy. So this exchange energy topic, it comes under the stability of an atom. Atom is stable or unstable is decided by the electrons. Okay, the outer electron it is half filled or completely filled, the atom is more stable. Okay, and another one reason, exchange energy. Okay, so till you know half filled and completely filled, you know very well. Okay, so now we are going to see the exchange energy. First we know the definition of exchange energy. Okay, and another one here, give one more point, half filled and completely filled. Okay, it is more stable than the partially filled. I give one example. Here half filled and completely filled, the element is more stable than the partially filled. Carbon is the partially filled element. This one for half filled element. Okay, so which one is more stable? Nitrogen is more stable. At the same time, now take the example for neon. Neon atomic number 10. Write the electronic configuration. 1s2, 2s2, 2p6, totally 10. 6 plus 2 8, 8 plus 2 10. So now here p orbital is 6 electron. So 6 electron means it denoted it is a completely filled element. So half filled and completely filled electron present in the outer valence shell, the element is more stable than the partially filled element. Are you clear? Okay, so now see the exchange energy definition. Two or more electrons present in the degenerate orbital. For example, p orbital, 3 orientation. Okay, d orbital, 5 orientation. Okay, so now here 1 or 2. Here also 1 or 2 or more electron it is present in the same orbital. This one for p orbital. This one d orbital. Okay, so next one same spin. The value is plus half plus half. This also plus half plus half plus half. So 2 or more electron the same spin and degenerate orbital. Degenerate orbital means same orbital electron it is present. Now this electron exchange to the next orbital, but at the same time it is the degenerate orbital. So during exchange their electron, now during exchange process the energy is released. So this energy is known as exchange energy. Okay, so here explain that whether it is the half filled or completely filled or partially filled, when more amount of energy is released. Okay, so which one? Now we are explaining 3 category. One is half and another one is completely. Okay, next partially filled electron. Okay, so now during which process release how much large amount of energy, so the particular element is more stable. Are you clear? Greater stability. Okay, so in half filled as well as completely filled. Okay children, so now the excess amount of energy is released means the particular element is more stable. That's all. Are you clear children? So now this concept I explain with the example. Okay, here I take the example as chromium. Okay, chromium atomic number 24. Electronic configuration, first write argon. Okay, so 3d5 4s1, 3d5 4s1 and another one 3d4 4s2. Okay, this one expected electronic configuration. Okay, so this one for actual configuration. So both also we are checking. So which one has more amount of energy is released. Okay children. Now to calculate the exchange electrons. Okay, so now in 3d5 4s1 for chromium. Take the example for chromium element 3d5 4s1 and another one 3d4 4s2. Okay, 3d5. So 1, 2, 3, 4 and 5. 5 electrons. Same spin. Degenerate orbital. Degenerate means the electron present in the same orbitals. Here d orbital, 3d orbitals. Okay. So now give the number 1, 2, 3, 4 and 5. Okay. So this first electron exchange to the second one. Okay. So this electron is moved to the next orbitals. Okay, not the different orbital. Okay, so next this also it is possible. So this first electron exchange to the third position and next fourth as well as fifth. So how many? 1, 2, 3, 4. So 4 exchange is possible. Are you clear? Okay, so same way for another one, 1, 2, 3, 4, 5. Now take the second electron. So this electron is moved to the next, move to the next one, move to the next. So totally how many? 1, 2, 3 exchange is possible. Okay, next once again 1, 2, 3, 4, 5. Okay, now take the third one, 1, 2. So how many possible? 2 exchanges possible. Okay, so now this electron is moved here, mean it releases some amount of energy. Okay, so same way 1, 2, 3, 4, 5. Okay, so now this electron, fourth position electron shifted here. Exchange is possible. So here totally only one exchange is possible. So now to calculate the total exchange, 4 plus 3, 7, 9, 1, totally 10 exchanges possible when in 3D5 4s1 configuration. Now come to the 3D4. Okay, 1, 2, 3, 4. Right, 1, 2, 3, 4. Okay, 1, 2, 3, 4. Here also 1, 2, 3, 4. Okay, so now this electron is exchanged to the next one. 1. Here also it is possible. Here also this electron exchange. So totally here how many? 3 possibilities. Okay, so next here this electron 1 and 2. Okay, so next this electron. This electron is exchange is possible to the next one. So now only one exchange is possible. Okay, so this is no need. Okay, so the total number of exchanges is 3 plus 2, 5, 5 plus 1, 6 exchanges possible. Okay, so from this we can understand the concept is half filled. More exchange is possible. More exchange means large amount of energy is released and stability is more. At the same time, this one for partially filled electron. In partially filled, how many exchanges possible? Only 6 exchanges possible. Okay, children. So here less energy. Okay, so stability is lesser. Are you clear? Okay, so here large stability and large amount of energy is released. Okay, so now see here degenerate orbital, same spin and half filled. Okay, based on the Hund's rule, now I just consider here this electron is moved to the next, mean here pairing takes place. Okay, children, same way for this electron it move here, mean pairing takes place. Here also, here also. So start pairing. So now it arises the completely filled is possible. Pairing takes place. Okay, so this also another one reason has that is more stability. Are you clear, children? So now you can understand why some elements it behaves as more stable. Okay, only two reasons. One is symmetry and another one is based on this exchange energy explain the stability character. Are you clear, children? Okay, so up to this the unit 2 lesson is over. Okay, I hope children you can understand all the concept. This quantum mechanical of atom is the fundamental in chemistry. Okay, so you must study, you must try to understand all the concept and side by side study thoroughly. Okay, so now this session I take the evaluate yourself problem. Okay, totally 8 question in the textbook, evaluate question. So now we are going to solve one by one. Okay, so before that I summarize whatever I teach in the unit 2 lesson. Till we cover the topic atom model, Thomson model. Okay, so in Thomson model talk about the structure of atom. The whole sphere is the positive, electron just embedded in the positive charge of an atom. Okay, so later on this concept is wrong. So second scientist is Rutherford. Rutherford talk about center of the atom is the nucleus and electron revolve around the nucleus. This is a Rutherford concept, and Bohr model it gives the idea about electron is very clearly. This electron move in the circular path. Particular path electron is revolve around the nucleus. Here Rutherford just electron is revolving, but here Bohr said in a particular path and give the path name also. N is equal to 1, K shell, L shell, M shell, N shell. Okay, so next one, de Broglie. Okay, so now de Broglie concept talk about this electron. Okay, electron wave nature. Okay, here derive the wavelength lambda is equal to h by mv derivation. Okay, so next one, Davison and Germer experiment talk about electron has the wave nature. Okay, electron has both character, particle as well as wave. Okay, so this Davison and Germer experimentally prove electron has the wave nature. Okay, so next one, Heisenberg uncertainty principle. Heisenberg also talk about electron. Okay, so it is impossible, Heisenberg concept about electron. Okay, in electron the position and momentum it is not possible to calculate at the same time. It is impossible to measure simultaneously both position as well as velocity, okay, and momentum. Okay, so next one, Schrodinger equation. So this is the basic. Okay, so based on this talk about the quantum numbers is everything. Okay, so here also talk about the wave nature. Here two concepts, time dependent as well as time independent. Okay, so next one talk about the topic quantum numbers. 4 quantum numbers is very important concept. Next one talk of here 4 quantum number principle, azimuthal, magnetic, spin quantum number, you know very well. So next one, shape of orbital, s orbital, p orbital, d orbital and f orbital. Discuss the shape. Next one, energy. Okay, so 1s, 2s, 2p, 3s. Here talk about the energy levels. Next one, filling of orbital. In the filling of orbital has a 3 concept. One is Pauli exclusion principle, alpha principle and Hans rule based on to arise the electronic configuration. So next one talk about the stability. Okay, if 2 element is given, they are asked them to find out whether it is stable atom or unstable atom. You can answer it is very easily. Just write the electronic configuration. Underline the outer valence electron. Okay, the element contain half filled or completely filled. The atom is very stable. Okay, so now if the element is not half filled or not completely filled, it is automatically say it is a unstable atom. Okay, another one way to calculate to find out number of proton as well as neutron, say the atom is stable. Okay, so the last topic, stability. Okay, so in the stability topic we studied the exchange energy. So this with the help of this exchange energy, they give the evidence about the stability of an atom. I hope children you can understand this lesson is very well. Okay, so now I am going to discuss the evaluate question. Okay, children, first I discuss the question number 8. Okay, evaluate yourself. Textbook page number 57. See the question. Which has the stable electronic configuration? Which element here contain ion? Okay, so if just writing nickel mean you say element. Here I put the charges. So in ionic state, okay, it contain the positive charges, so cation. So it is a metal. Okay, children. So here two ions given. One is nickel, Ni, nickel, plus 2, and another one is Fe ion, okay, plus 3 state. Which one is more stable? Not more stable, which has the stable element, stable ions, okay. You know how to find out. Okay, so in what are the ways to find out is very simple. What is the condition? Write the, if any element is given, write the electronic configuration. Point number 1. Next, underline the outer valence electron. Okay, in outer valence electron, the electron, okay, the last orbital, the electron is half filled or completely filled. The particular element is stable. That's all. Okay. So now take the nickel, Ni. Okay. Atomic number 28. Write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6. Okay. 4s2. Okay. 3d8, 4s2. Okay, now count it. 2, here totally 10 electron. Next, this one, 10, 20, 28. Now question is Ni plus 2. Okay, so plus 2 means last this 2 electrons. So what about the electronic configuration in Ni2 plus? 1s2, 2s2, 2p6, 3s2, 3p6, okay, 3d8. Here 4s2 electron is last. Very clear? So 3d8. So now this is the outer valence electron, 3d8. Here d orbital, how many orientation? 5 orientation. 1, 2, 3, 4, 5. How many electrons? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Are you clear, children? Okay. So now take the next one. Fe, ion. Okay. Fe, atomic number 26. Write the electronic configuration. Okay. Children, another one trick. Here total number of electron, here 10, 3s2, 3p6, 8. Okay, so instead of this, write like this, argon. Okay, 3d8, 4s0. So this is the another one way to write the electronic configuration. Both also same. Are you clear? Okay, so based on this, I am writing ion. So here write the electronic configuration ion, argon. Okay, argon atomic number 18. Okay, so up to way completed. So remaining 3d as well as 4s. Here 2 electron. First to fill the 4s. Next come here. So 18 plus 2, 20. Remaining 6. 3d6. Are you clear, children? Now come to the higher section. So based on this, practice means is very easy. Don't write 1s2, 2s2, 2p6 always. Don't write like this. Take practice for this pattern. Okay, so 3d6, 4s2. Now here question Fe plus 3. So in Fe plus 3. Plus 3 means what is the meaning? Last 3 electrons. So write the again write the electronic configuration, argon. Okay, so here 2 and 1, 3 electron it is last. So what about the remaining? 3d5, 4s0. Okay, so now outer valence electron, 3d5. Okay, so d orbital, 5 orientation. How many electron? 5 electron. 1, 2, 3, 4 and 5. Children, I hope you can say the answer is very correctly. Which one is the correct one? Which ions? Nickel plus 2 or Fe plus 3. Which one is stable? Can you guess the answer, children? I hope you can guess it. Okay. So what is the correct answer? Fe plus 3. Why? Here half-filled orbital present in the outer valence. Here d orbital. Here how many electrons present here? 5. So it is the half-filled electrons. Okay. So now Fe plus 3 is the stable. Are you clear? So this is the way to find out the element is stable or unstable. Are you clear, children? Okay, so write the answer. Fe plus 3. Okay, it's the stable electronic configuration. Unstable ion. Okay. Next question. Explain the meaning of the symbol 4F2. Write all the 4 quantum number for these electrons. Once again, explain the meaning of the symbol. Symbol here 4F2. Okay, 4F2. Wanted to explain about this. Okay, so this 4 denoted. Next F denoted and this number 2 denoted. What is this? Explain. And next one, write all the 4 quantum numbers. All the 4 quantum numbers means you know what is a 4 quantum number? N, L, M, S. This is 4 quantum numbers. Okay, 4 quantum numbers. About these electrons. This electron mean this 2. Are you clear? Okay. This is the question. Now you can understand very clearly about the question. Okay. In the problem question, minimum 2 times read and next to start write the problem. Okay. So here this 4 denoted as principal quantum number. Principal. Okay, quantum number. You know the symbol principal quantum number N. This one. Okay. Next one, this F denoted as the orbitals. Okay. So what is orbital? F orbital. Okay. You know only 4 orbital. S orbital, P orbital, D orbital and F orbital. So here F orbital. This 2 denoted as electron. Okay, electron, that's all. Okay, so now you know the meaning. 4 denoted as principal quantum number, F denoted as the F orbital and 2 denoted as the electron. Okay, so now see here, within this N value is equal to 4. What about the L? What about the L formula? L is equal to N minus 1. Okay. So, N minus 1 means, now what about this 3? Okay. So, next one, find out the M, magnetic quantum number. What is the magnetic quantum number formula? Minus L, 0 plus L. Okay. So, now here L, 3. So, minus 3, minus 2, minus 1, 0, okay, plus 1, plus 2, plus 3. Are you clear, children? Okay. So now here only 2 electron is given. Okay. So 2 electron. Okay. So at the same time, now this one F orbital. F orbital, how many orientation? 7 orientation. Okay. 1, 2, 3, 4, 5, 6, 7 orientation. Here how many electron? 2 electron. 1 and 2 according to rule. Okay, don't put here. Okay, so now represent the values. Okay, denoted as minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay. Question is write all the 4 quantum number for these 2 electron. Okay. So now first take this minus 3 and next one minus 2. Okay. So in minus 3, 3. Here minus 2. About this 2 electron we are going to fill. Okay, so in minus 3, this electron, what about the n value? N value, what is the n value? 4. This minus 2 also, what about the n value? That also 4. No problem. Okay, so next one, L value want to write. Okay, so this repeatedly I insist this one. Now L value 0 s orbital, L value 1 p orbital, L value 2 d orbital, L value 3 f orbital. Okay, so now what about the L value? 3. Here also this one f orbital, so 3 orbital. Okay, so next to fill the m. Okay, magnetic quantum number. What is the value? Minus 3. Okay, this electron, what about this? Minus 2. Okay, so now to fill the spin quantum number. Okay, so this one, electron, same spin. So here enter as plus half, plus 1 by 2. For this electron also plus 1 by 2. Are you clear, children? So this is the way to find the answer for this question. Okay, once again I will explain meaning of 4f2. Right, 4f2. 4 denoted as principal quantum number, f orbital, 2 electron. Okay, so now write quantum numbers, n value. Okay, next L value formula n minus 1. Next m formula minus L, 0 plus L. Next S formula plus half or minus half. So only 2 value. So same spin, the half filled plus half. Okay, again we pairing minus half. You know very well. So next to write the 4 quantum numbers about this 2 electron. First I take this minus 3 and minus 2. Okay, in minus 3 for this one, n value 4. Okay, L value 3. Okay, this rule. And next m value, see here and write minus 3 and only 1 electron, so plus half value. Same way for next also. Okay, children, we want to note one point. From this we can identify here n value same, L value same for this 2 electron, S value same. Which one is different? M is different. Okay, so from this can you guess, children? This is in which rule? We studied the 3 rule. One is alpha principle, second one is Pauli exclusion principle, and third one Hund's rule. Okay, children, can you guess this one which rule? Are you guess it? I hope you can guess it. Okay. Okay, so now which rule is obey this tabular column in? The second one, Pauli exclusion principle. You know the definition of Pauli exclusion principle. No 2 electrons can have same set of 4 quantum numbers. Okay, within this 2 electron, among the 4 quantum number, any one quantum numbers are different. Here magnetic quantum number is different. Are you clear, children? I hope you understand this session, and to maintain the note and write the problem. Okay, so hereafter I completing evaluate yourself. Next do the problem book backside exercise, children. Okay, so to maintain your note and study properly. Thank you.